Question 6. A loan of $10,000 has interest charged on a reducing balance at 6% per annum, compounding quarterly, with quarterly repayments of $700. The balance after 6 months is A, B, C, or D. Looking through this question, there's two words that stand out for me. Reducing balance. If you have a look at your formula sheet under the subheading Finance, you will find a recurrence relation for balance reducing loans or reducing balance loans. And we're going to use this formula to solve our question. So before we can use this formula, we need to write down some pertinent information that we can sub in. So let's have a look here. First of all, let's have a look for R. R is going to be 1 plus our interest per period. Now, if we have a look back at the question, it says our interest is 6% per annum, but it's compounding quarterly. So what I need to do to that interest rate is divide it by 4, so I find out my quarterly interest rate. So to do that, I'll rewrite my percentage as a decimal, 0.06, and I will divide that by 4. Okay, what's next? We have capital R. Our repayment for each quarter is $700. Our initial amount, A sub 0, is going to be $10,000. So let's rewrite our formula using the information I have here. So we have A n plus 1 equals R, which is going to be 1.015 multiplied by AN minus 700. And our initial balance that we borrowed, A sub 0, is $10,000. Now, there's a really quick way to do this on our calculator, guys, and I'll show you right now. Let me just move this statement up here so I can read it later. On our calculator, we're going to start with how much we borrowed from the bank. So we're going to put in $10,000 and we're going to hit enter. Now, what I'm doing to this initial value is I need to multiply it by 1.015. Let's try that again, 1.015. And then I need to subtract $700 from it. Now you notice here that it says answer times 1.015 minus 700. That means when I push the enter button, it's going to give me an answer. And then if I push the enter button again, it will find that answer and repeat the same procedure to it. So using that information, at A1, we got $9,450. And at A2, we got $8,891.75. And that's the answer I want, because it says, what is the balance after 6 months? Well, if you think, how many quarters are there, or how many quarter of a year is there in 6 months? There's 2, isn't there? So that means I'm looking for A2. So the solution to question 6 is B, $8,891.75. Question 7. What is the length of the minimum spanning tree for this network? All distances are in kilometers. For any network, there may be more than one spanning tree possible. And if the weight for every spanning tree is found, there'll always be one tree or trees that are smaller in total weight than the others. So we refer to these as our minimum spanning trees. Now, one way to find the minimum spanning tree is using what we call Prim's algorithm. And we're going to touch on it slightly here. So hopefully it sets some foundation for questions you might be asked in the future. So for the Prim's algorithm, we choose any one of our vertices. Let's choose P. And we look at the edges that come out of P. You've got one with a weight of 4 and one with a weight of 5. So we choose the smallest weight, which is 4. And we'll connect P then to Q. Now I need to look at the vertices P and Q and look for the edge that has the smallest weight. Now if all edges are the same weight, it really doesn't matter which one you pick. So we may as well choose the middle one and bring Q down to S. Now we look at our vertices P, Q, and S, and we look for the smallest weighted edge that comes out of P, Q, or S, and we draw a line across that one. So coming out of P and S, we have 5. Coming out of Q, we have 5. And coming out of S, we have 3. So we're going to take the edge that is weighted 3 all the way over to R. Notice now that all my vertices are connected. So we have developed a minimum spanning tree. And to find the weight of that, we just add all our edges together. So our weight will equal 4 plus 5 plus 3, which gives us a weight of 12 kilometers. So our answer for question 7 is C. Question 8. The following scatterplot shows a linear association between two numerical variables. Choose the best description for the direction and strength of the association. A, strong positive, B, strong negative, C, weak positive, D, weak negative. When answering these questions, guys, we need to draw in our linear line. So we could draw in our least squares regression line just by eye. I could put that right about there. And then I need to look, okay, what direction is that line sloping in, and how close together are my data points clustered around that line? So when I look at this, I need to look at two things. I need to look at direction and strength. In the direction, if it's going from left to right and the arrow or the line is increasing, we say it's positive. Going from left to right, if it's decreasing, we say it's negative. So looking at the question 8 here, from left to right, it is going downwards. So we say it is negative. So straight away, A's out and C's out. Next, let's have a look at the strength. When the dots, or the data points are super clustered together like that, we say they are strong. If they're open up a little bit, moderate, and if they're quite far apart and scattered, we say it's weak. So our question 8 graph here, the points are pretty close together, so we're going to go with strong, which means the answer for question 8 would be B, a strong negative association. Question 9. It is observed that as the number of ice blocks sold each month increases, the number of fans sold also increases. Which of these statements is therefore true? A. There is a negative causation between the number of ice blocks sold and the number of fans sold each month. Well, first of all, guys, there's a big giveaway in this statement here. The use of the word causation. A scatter plot can never show causation, right? It shows association and it shows correlation, but those two things do not lead to causation. So any questions that you'll face within your test where it's saying there is a negative causation or there is a positive causation, you can reject those straight away. So A is definitely out. B, there is a positive causation. B is definitely out. Now, if it did say there might be a negative causation, well, sure, there might be. But the only way to confirm that is perform a completely random experiment. A graph will never be able to tell us this information. So let's have a look at C. There is a negative association between the number of ice blocks sold and the number of fans sold. Or D, there is a positive association between the number of ice blocks sold and the number of fans sold each month. So if I have a look at a graph here, our question says the number of ice blocks sold each month increases, the number of fans sold each month increases. So you would imagine if you were only selling one ice block, you'd imagine only about one fan or two and three. But when you start getting up to 7 ice blocks, you would expect 5 or maybe 7 fans to be sold, 8. Then maybe there were 6 or 7 fans sold for every 8 ice block. So you'll notice as the ice blocks increase, the number of fans also increase. So we end up with a least squares line there that is positive. So our solution for question 9 will be D. There is a positive association between the number of ice blocks sold and the number of fans sold each month. Question 10. Which of the following graphs represents a time series plot with a 3-point moving average? Now the key words in this question are 3-point moving average. Now what a 3-point moving average does, or what any moving average does for that matter, is it takes this time series plot and it smooths out the data. So to get rid of the fluctuations in order to help us make better predictions in regards to the model. Now, in order to do a 3-point moving average, if we were to look at our graph, what we're doing is we're looking at the points in position 1, 2, and 3. So if you look at the little graph I've drawn here, you've got the points in position 1, 2, and 3. Now to find the 3-point moving average, I would take those 3 points, add them together, and divide them by 3 to find my average. And I would write that answer in position 2. Next, I would add my second point, third point, fourth point together, divide them by 3, and write that answer in position 3. And finally, I would take the third point, fourth point, and fifth point. I would add those together, divide them by 3, and write my answer in position 4, making myself a 3-point moving average. So the key things to note here, guys, is when I made my 3-point moving average, there is nothing in position 1 and there is nothing in position 5. So if we look at A, our first point on our moving average there is in position 1. So A's out. Same with C. Our first data point is in position 1. So C's out. So B and D are still viable. But if we have a look at B and D, notice how D, after the second point, has a data point at every single other point, and it finishes 1 point from the end. So just like our 3-point moving average that we did in blue, you don't start at the start, you don't finish at the end, you start one in, and you do every point. So the answer to question 10 is D.